Hi, and welcome to this video on square rooting radicals with negative radicands. It's going to introduce the idea of imaginary numbers. So why don't we talk about what a negative radicand is, or a radicand, I should say, just a radicand, is in fact the number under the radical sign. So if I had the square root of x, it would be x that is the radicand. Okay? This video also assumes that you're very versed in another skill, which is simplifying square roots that have positive radicands. Here, the radicand is 200 when I write the square root of 200. And you should be very fluent and apt to ask that great question of what is the biggest perfect square that goes into the radicand. In this case, it's 100, so I rewrite it as 100 times 2. And then I just apply the properties of perfect squares with square roots and say, what's the square root of 100? It's 10. What's the square root of 2? Can't simplify that, so the answer is 10 root 2. You need that skill as we move through these examples. So really what I'm going to do here is I'm actually going to incorporate this skill with this fact right here. This fact is the definition of the basic imaginary number, and it says the square root of -1 equals I. Now, why do we refer to it as the imaginary number? Because previously on your calculator, if you've ever encountered trying to take the square root of a negative, and I'll take any negative number, your calculator would say non-real answer. Well, this indicates that there is no real number for the square root of a negative, but there is, in fact, an imaginary answer. And they're all based on this idea of the square root of -1 equals I. So let's take a look at these examples here. This is a pretty easy skill. I think you're going to acclimate to it very quickly. It just takes a little practice. Directions, please simplify the following expressions. So in number 1, where it says the square root of -36, I notice very quickly that it's a negative radicand. Well, anytime we have that, you should rewrite the expression breaking off a factor of -1 from the radicand. So I'll rewrite -36 as just -1 times 36. And then what I'm going to do here is just scan the problem and notice that it's got the square root of 36. So I will say that that is 6. And then it also has the square root of -1, which I will in fact say is I, making the answer of the square root of -36 6I. Okay? A little more complex example, barely, because I'm dealing with the opposite of a perfect square in the idea of -48. The square root of -48, again, when I see this square root of a negative, I rewrite the expression as -1 times the factor that is appropriate. In this case, it's 48. Here I'm going to now ask myself, what is the biggest perfect square that goes into 48? And that, in fact, is 16. So I'm actually going to rewrite this as a product of -1 times 16 times 3. And then I will just use my ability to square root perfect squares combined with this fact that the square root of -1 equals I, and move forward and do the following. The square root of 16 is 4. The square root of -1 is I, and I don't really know the square root of 3 can be simplified. In fact, I know it can't, so I just write the square root of 3. So the answer here is 4I root 3, or 4I times root 3. Both are legit to read those that way. Okay? So, moving right along to the next example. We'll try and leave the top of the page where it says the square root of -1 equals I. I notice here that the expression I need to simplify sits inside a binomial. So make sure you respect the order of operations here and don't try and do that subtraction. You can't, because you have to note that multiplication first. So I'll do the following. I'll put this in a little orange box here to go into the margin with it. And I will pull down my -2 minus 3 times this square root of -60, which I then just break off the -1 from the 60. And then I ask, what is the largest perfect square that goes in the 60? And I believe that it is 4. So I'll write negative 60 is a product of negative 1 times 4 times 15. And then I will, in fact, just say that the square root of 4 is 2. The square root of negative 1 is I, and the square root of 15 is just the square root of 15. So I now need to sort of reinsert this back in the problem, respecting the fact that this was multiplication here. So I do get that this is negative 2 minus 3 times, I'll write this in orange so you see where it came from the margin, 2I root 15. Well, that does allow me to continue to simplify and do this multiplication, for which I now will get negative 2 minus 6I root 15. In that these are not like terms in this binomial, I cannot simplify any further, so that is my final answer. Okay. Now, this answer is a little more complex. This example is a little more complex looking. And where you're going to find an example like this is important. It's when you start addressing imaginary numbers while using the quadratic formula. So I kind of set this up to look like an expression from a quadratic formula problem. It's not exactly that. It doesn't say x equals, but you're going to find this particular skill in the quadratic formula. Okay, when in fact the root you're finding is an imaginary root. So pay special attention here. So I notice here when I have the quantity of negative 2 plus or minus 8 root negative 75, all divided by negative 6, I notice quickly that it has a negative radicand, which I will do in the margin. Okay, so the square root of negative 75 is rewritten as square root of negative 1 times 75. And then I ask what's the biggest perfect square that goes into 75, which is 25. So I rewrite it as a product of negative 1 times 25 times 3. Again, always respecting that every line of my writing is just rewriting the same expression. They're all equivalent. And then that leaves me with saying that the square root of 25 is 5. The square root of negative 1 is I. And then the square root of 3 is just the square root of 3. So I need to reinsert that in the problem. When I do negative 2 plus or minus 8 times this, so I'm going to say 8 times 5I root 3, all divided by negative 6. And if I continue to simplify, I'll be able to do this multiplication. So negative 2 plus or minus 40I root 3, all divided by negative 6. And now that means I will apply the distributive property here. Sort of distribution, it really is. Multiplication by negative 1/6, or simplifying both these fractions by dividing by negative 6. And that is going to give me negative 2 over negative 6 is a third, plus or minus, now be careful here, we've seen this before, 40 over negative 6 is going to give me a negative. But plus or minus a negative is the same as plus or minus a positive. You will get the same result. So I just forgo the negative. I'm going to write 20/3 I root 3. And that is my final answer. So what are we getting at here as an overview if we take a look at the problem? The problems here is you've got to be able to manipulate radicals that have negative radicands. And this brings us into what we said was the imaginary number. Okay, imaginary numbers in terms of their operations extend past this. This is just a little intro in how to deal with imaginary numbers while dealing with negative radicands. You'll see examples of doing operations with I elsewhere. This is kind of a very basic way of addressing them by introducing them with the idea of a negative radicand. So feel free to rewatch and practice, and I hope this was helpful. Bye.